Right. Hello everyone. Good afternoon. This is Shahid, and today we'll be covering first session on decentralized apps using blockchain as core technology. So, in one of the sessions, I've covered about the things that we were doing in Accion Labs about with blockchain, mainly with a public blockchain such as Ethereum. We chose Ethereum as a public blockchain, and a few applications we built for the demo on Hyperledger. I just want to make sure everyone able to hear me right, just to be safe for side.
Yes.
Yes, we can.
Cool.
Yeah, we
Cool,
can.
cool, cool, cool. All right, just hide this thing. All right. So mainly one of the core advantages of blockchain was that it allows you to have a completely peer-to-peer system that can be used for cryptocurrency, which is the main uses as of this moment as well. But this core philosophy of no central authority has actually created like web of application that can be built uh, on the blockchain network, not just the cryptocurrency or finance applications, but it could be anything that we as of now use where there is a trust involved. And these kind of applications are actually called decentralized apps or DApps in short. And we'll be covering about decentralized applications from the basics to the theory with the installations of various tools that we need till and in these all three sessions. And we will also develop small applications with each and every technologies just to get our hands dirty and know how these things actually work. So in today's call, we will actually learn a little bit about fundamentals, about DApps. We'll learn the main key component or key player in the decentralized application as of this moment is Ethereum and the smart contracts that majority of the organizations or open source developers are using. And then we will cover another very interesting and popular project that is going on right now that we also have very extensive experience, that is IPFS and LiquidToBe. And at the end, we will set up the development environment that we require in order to develop decentralized applications. And so on in the next sessions, we will cover completely Ethereum based. And in the last session, we will cover everything about IPFS and all the tech stack that we require to build uh, decentralized application using IPFS Stack. So let's begin. So like I said, the blockchain was initially developed for a Bitcoin. Basically, blockchain came as a like a hidden tool or hidden part of the Bitcoin cryptocurrency developed in around 2008, 2009 by Satoshi Nakamoto. Bitcoin became popular, and due to that popularity, everyone started coming to know about the underlying technology that was powering Bitcoin, and that's the blockchain. What blockchain actually has, it's a peer-to-peer decentralized way of storing a distributed ledger, a ledger which stores your money, right? One of the key component of everyone's life. And even though it's public, there is hardly any hack yet happened on the Bitcoin network, except few leaks and here and there where people actually share their private keys and everything. But the network is solid. The blockchain that powers the Bitcoin is still solid, still intact. The hashing that those guys use, the Merkle trees, which is distributed Merkle trees they use to store the information, is still intact and not able to basically hacked by any other people except quantum computers, but that's a different scenario. Quantum computers basically can decrypt any encryption actually. If you put that aside, taking the financial world in the aspect where money is involved and having the public network that powers the money and circulate the money from one people to another and keep the record in a public network and it's still not hackable is a very amazing thing. And that's how blockchain came into picture. Everyone started taking it into basically research begins on blockchain, mainly on the cryptocurrency, and people started to wonder, can we just take out the blockchain part from the Bitcoin network, develop it as an open source or some kind of subset, and see if we can develop applications on top of that. Well, it was very difficult on the Bitcoin network because Bitcoin was solely, the blockchain that was powering Bitcoin was solely designed to actually support cryptocurrency only. There was few features such as scripts where you can write few if and else conditions, but it was not like complete Turing machine or Turing complete blockchain where you can actually execute your code instead of just transferring few currencies in a form of hashes. And that's when Ethereum comes in, right? So before we move further, I just wanna tell you a little bit about the tech stack. This is where we are very generic, and of course there are many other layers as well. But this is how we design our DApp. You have your user interface, you have your business layer, but instead of a database layer or instead of like cloud layer where you store your information, you have a blockchain or distributed ledger. So first two layers has to be same. So the application that UI and UX guys are doing right now, they'll do it in the similar way. The business layer where you develop APIs or serverless codes will be same. The only difference is that you will execute smart contract if required. It's not mandatory. But the data that will be stored, it has to be a distributed ledger. Could be blockchain, could be any private distributed ledger, that's okay, but it has to be stored in a distributed peer-to-peer network, and it can't be stored in a normal database or a file system or anything like that. And if the blockchain or the distributed ledger layer is public, then it's a win-win scenario, because the more the peers are involved in your network, the stronger it becomes to basically take over. And the only way to actually take over the blockchain network is control 51% of the peers. So basically, if you see right now, the Ethereum has more than 1.5 billion peer across the world. So if someone wants to take over, they have to take over the peers, half of the 500,000, like 75,000 peers, which is business wise not feasible, because instead of wasting that many resources to take over the network, one can become a miner and earn a lot of money, but it's a different part. So after Bitcoin, the Ethereum came as a Turing complete blockchain network. So Ethereum does not only just support cryptocurrency, it allows you to actually write a program, which might have heard as a smart contracts, which are nothing but a program that can be executed on a network computing resources. So consider a cloud network, for example, right? The way we execute as our code now is just store or run our code into a machine which is publicly accessible to everyone. And here the scenario is same, except that the computing power comes from the collective network. So if you see that there are, let's say, 1,000 peers who are in the Ethereum network, and they have like 1 GB of the RAM or computing resources, for example, then your code can actually have access to 1,000 GB of RAM, and you can execute your code into the network. And of course, you have to pay for every execution line. So that's the difference I will explain. So Ethereum gave you complete Turing complete. Turing complete means that you can do complete computing operations that we currently do in any programming language, such as C, Java, or whatever. And you can execute that into the Ethereum network. So if you go by the definition, it's an open source, of course, peer-to-peer, globally distributed public computing infrastructure. This is very important, that runs a program called smart contracts and maintains the system state changes using the blockchain and cryptocurrency collision. Now, first part is distributed public computing infrastructure that I have explained, that your program has access to the collective computing infrastructure of Ethereum peers scattered across the world. And each of the peers have the same state level. So if there's any changes in one machine, everyone in the world, every Ethereum peer in the world, first replicate that changes. So basically your state is, every machine shares the same state. There is no different state into the network. So that makes your complete computer system, basically the way we run our computers, is that state is maintained at every single time the new instruction is executed in your processor, the new state is maintained. And so the same scenario here, but instead of like a processor, you have like millions of computers on which you can execute your program. And in order to execute your program, of course, you need to pay. and you basically you pay in the cryptocurrency that Ethereum supports, native currency, which is Ethereum, and in a short form it's called Ether also. And like we said, Bitcoin was developed for cryptocurrency, but Ethereum was developed for general purpose computing infrastructure. It allows you to write a program, compile it. Basically, it executes only bytecode, so it's very fast. And you can just, after compilation, you can run that smart contract into the network, and you can share that to other developers as well. And basically, they'll pay the amount of Ether or cryptocurrency in order to run it. Now coming to one small doubt that majority of DApp developer or smart contract developer has. You don't have to write each and every logic. Let me just go back here. What I said, that you don't need to write each and every business layer into your smart contract, because like I said, you need to pay for every line of code execution into form of money, right? So you only write the code which is completely required, and you make sure that it takes less time and less space. Time and space complexity of your program has to be as minimal as possible in order to make your incentive or the incentive of the program go low. Otherwise, if you write complete business layer, you basically go bankrupt, because you need to pay so much money in order to run your infrastructure into the network. So just keep that in mind. You need to execute only the code which is required. Otherwise, you can write any other things, such as your normal business logic into your normal code base, such as Java, Node, Python, whatever you do. But only the things that is required, such as transferring money from one account to another, that smart contract you can basically write into the chain and run it. And you pay a very minimal fee, because transferring money from one account to another is like 5-6 lines of code, and that requires basically very less amount of money. But instead, if you write complete business logic, that will basically charge you, the network will charge you a lot of money on that. So keep that in mind. So one thing that, okay, let me just go back again here. So like I said, the smart contracts basically is a business logic, right? So anything which is not business logic, that could be your files, static files, or images, or database, basically. These kind of storage, basically this Ethereum is not actually a storage, it's a business, or you can say computing infrastructure where you run your code. In order to store your files or store your database or basically create anything, you need to use a blockchain layer. And that is a layer that either you can maintain or you can rent from any third-party provider, or basically can use any infrastructure as a service to connect and store your files into the blockchain layer. And that's where basically Ethereum and IPFS comes in. And that's where advent of decentralized applications comes in. If we see here, this is the Ethereum stack where developer can use in order to build applications or DApps. So you use your normal JS, HTML, CSS for the front end. You can use Ethereum smart contracts to execute your smart contracts for any need. You can use Ethereum Swarm, which is a file storage, peer-to-peer distributed file storage, to basically store your files. Or you can write an abstraction layer and make it like a database. And we will share, or we will learn one of the very popular peer-to-peer database as well in the coming session. Whisper is currently in development. This is the communication module where one decentralized application can talk to another decentralized application, similar to how we do using RabbitMQ and other public subscribe queue messaging system. So Ethereum provides you smart contracts and Swarm as of this moment to handle your business logic and your distributed ledger or storage layer requirement. And of course, you have Ethereum blockchain to store any of the transaction information that will last forever as long as network is up, to solve any issues. So basically, you have your third party issue solved because you already have Ethereum. But if you wanna write smart contracts to handle your business logic, you can do that into smart contract. You want to store your files, your database, or any third party or static files, you can store in Swarm. So your complete needs, and of course you can do JS, HTML, CSS. You can use this to develop your front end. So your complete stack is solved by Ethereum. So you use your normal front end technologies to develop front end of the application. You use smart contracts to develop business logic. You can use JavaScript or Node.js or anything to develop API layer if you want to. You can use Swarm to store your files like images or videos if your application requires. And you can use Ethereum blockchain to store any transactional information of your application, just to keep the ledger and keep the, you know, conflict resolution at its best. Because once it is in the blockchain, it can't be changed. So that solves all the conflict issues. So this is the stack that Ethereum provides you. But one of the key advantages here is that Ethereum is very uh, stable right now, and it has so many peers. So the stronger the peer, like I said, the more the peers you have in your network, the stronger your network becomes. So yeah, there is a reliability thing here. The only disadvantage is that you have to stick to Ethereum only. So you can't. I mean, smart contracts can be written in Solidity only, and even though they provide many software development kits, but you can't step away from Ethereum. So you have to stick to Ethereum only, and you can't use any other technologies if you want to. Which is where, to fill that gap, the project called IPFS Stack comes in. This is a project from protocol.ai. So they provide an open source stack, which is uniform layer stack where they are not dependent on any other blockchain. You can use IPFS Stack with Ethereum, with Bitcoin, with any other blockchain that is coming right now. And they provide very open source kind of and very, how can I say, a generic module kind of thing where you can use it, or you don't want to, you can't. For example, so these three things are required. So first thing is LiquidToBe. This is very similar to TCP/IP stack, if you remember. First thing is your LiquidToBe, which is a kind of a network layer thing, which you may use it or not. Most probably you don't need that if you're developing a generic decentralized app. So what LiquidToBe does is it maintains the network information, and it maintains the peers information into your machine, and the connection to another peer, exchanging data to another peer. Sorry, maintaining connection to another peer is done by the LiquidToBe only. So routing your network, your data exchange is done by LiquidToBe, and they also allow you to form public pub-sub networking kind of thing to another peer without having any central authority. The next stack is IPNS and IPLD. IPLD is the storage layer of the IPFS. So IPFS is basically interplanetary file system, and so any IP is basically that. So the IPFS uses a distributed Merkle tree algorithm. We'll discuss that later. So basically, a Merkle tree is very similar to binary trees, except that each node of the tree is hashed with a normal SHA-256 or any other hashing algorithm. SHA-256 is recommended. And distributed Merkle tree is where you use each of these Merkle trees into different peers, and any changes into the node is synced to another peer as well using LiquidToBe. And the IPFS stack is basically, it helps you to store your files. It basically deals with your files. You can store your file and share it across anyone in the world. We will do that later, and in this session only. And you can use IPFS as an abstraction layer to develop your database applications. And we will discuss OrbitDB, one of the very popular IPFS based peer-to-peer database. So using OrbitDB, you can use it, or using similar way you use MongoDB or any other document store database. But in the core layer, it uses IPFS. So you use a peer-to-peer network, and it doesn't store your information at one machine. So if there is any failure in anything.
ब्लॉकचेन ऑप्शन के बारे में कुछ पता ही नहीं है, क्रिप्टो करेंसी ब्लॉकचेन
Any questions? Hello.
Sevanti, were you asking any question?
No, Neelam. Sorry, I was on.
So
no problem.
Then we can continue.
Okay. So we will go into the Ethereum into detail in our next session, and the IPFS will be our last session. In this, we will basically learn about little bit about smart contracts and little bit about each and everything to actually understand and make you understand that you can use either of these stack to develop your DApps. You're not limited to using any single thing. You can use combination of these to basically build your application. For example, you can use IPFS and OrbitDB and Ethereum as a blockchain to build your application, such as, for example, just out of the mind, a decentralized file system where one can share a file, and each of the shared file and the action of it will be recorded into the chain. So let's say, if you guys know, let me just I'll just show it later. For example, you might have heard about pixels.com or any other photo sharing application where photographers share their applications or their photos, and there is a copyright issue, right? The upload, the basically the software that, for example, Pixels or any other photo sharing application, they make sure that people don't steal photos and everything, and the authoritative photographer gets paid for it. But still, photos are being stealed out and sold in the black market or in uh, dark web. So one of the key applications that you can build using IPFS and Ethereum blockchain is a decentralized blockchain-based image sharing system, where user can basically upload an image and license it on his name or using his private keys. And if anyone uses that, then the record of that will be stored into the chain. So there is a conflict resolution, and of course the payment will be paid directly to the uh, owner who owns the image. That's the idea of the blue. There are many you can do. And in the end, we will actually do set up the dev environment. And I want you to actually, if you guys have the access, if you're joining from the laptop only, do make sure you install all of this together with me, so that in the next sessions, we don't have to have any installation issues. So let's first go to uh, Solidity, and let's understand, what Solidity is. And just a sec. All right. So Solidity is another high-level object-oriented programming language, just like C++, Java. But it is actually, if you go through the syntax, it's mainly combination of JavaScript and Java. So they use all the OOPS principle, and they allow you to write syntaxes in the JavaScript, which is very familiar because it's been used in front-end layer and back-end layer as well. And of course, it's the compile time language. So you need to first compile your program, convert it into bytecode, and then execute it. So you can install Solidity just by running this command. You can install manage also, and you can use it from Docker as well. But generally, people go through npm. If you don't have npm, you can install it from Node.js module. Very easy. Once you have Solidity compiler, you can basically write and compile your program and run it. However, I would not recommend you to do this. You can just directly do via Truffle. We'll explain that in a moment. So let me just go through a little bit of example here. Yeah. So Solidity, the program written into the form of contract. Contracts are like classes, you can say. But since it's a complete immutable language, so you're here, you have to declare your variables only and only when you use it. Because like I said, you need to pay for it, right? And you need to make sure that the variables that you're using should be very tightly space constant. So like I said, your program has to have a time and space complexity as low as possible in order to make sure that the amount the computing infrastructure takes is very less, so that your fees does not go high. And here, for example, you can store, there is an int, float, class, arrays, and all of these state types. You can check into this. I will share that through the email. Here, the first line is very important. You need to explicitly say which Solidity compiler this program needs to use. This is very important. Once you do that, you can write your contract, which is like a class. This is the name of contract. You can store all your variable. You can write a functions, very similar to how we do in Java. Here, you need to explicitly say that it is a public or private kind of a function. So the execution concept. And this payable means you can use this function in order to perform some kind of payment transfer. Even if you don't do that, you can still do it, but Ethereum allows you to basically declare a function as payable. so that it registers in compilation time only. I will share you the types which are very similar to how we use it in the booleans. For example, it's bool. The integer is signed and unsigned, both is supported. And you need to, like I said, you can declare from size 8, which is a default size, to 256. Only use the size which your variable wants to. Don't go by default 256 or by default 8. You need to make sure that whatever variable you're using, you have the size before in mind, so that you declare a variable like that. For example, int 16, int 32, int 64. So declare like that. Don't go with default variables. These are shift operation that we do normally in any code. I'll show you the, yeah, another which is fixed point number that floats. Here you can use again sign and sign, and again you declare it with the variable numbers. So the way fixed side is declared is using the m into n. This is like if m is basically divisible by 8 and goes from 8 to 256, and can be 0 and 18. So n is basically your what do you say? Let me just give an example here. So compiler stores 8 bits of fixed size, but it allows you 3 precisions. You can go from precision till 80, and you can go, of course, to 256 into the fixed sign and sign both. Yeah, this is very interesting. The address type. This is a new type that is not available with any other programming language. So address basically allows you to store the Ethereum addresses or create Ethereum addresses into the programming language itself. So of course there is payable address. It's just payable address allows you to basically do the money transfer or receive the money into that particular address. But if you don't want to, you just want to store an address as a like a data type, you can just use an address type. Rest, there is like strings, hexadecimal, enums, which are very common in other languages, so I won't go into that. Address is the one which is new, and the way they stored fixed point numbers is very different than any other language I've seen. So I'm not sure. I know Java doesn't have that, Python, not even JavaScript. So I've seen this in a very unique thing in Solidity, where you need to specifically decide the precision number before you actually use it, and you have to use that because otherwise you waste your resource and you pay for it. Yeah,
The address is kind of pointer or something.
no, not pointer. No, it's like hash. So for example, let me just show you Ethereum address. So there is a website called Etherscan, which is a public Ethereum chain website. So if you see here, let me just go to any block. Due to transaction. So this is mined by, right? So this is the address. So this is a address. It's a payable address, minor address basically. So this is a type of address that I'm going to use. Yeah.
So this address is specific to the block.
No. And it's a hash basically. It's a SHA-256 hash. Start with 0x only in Ethereum. It's where you can send money from, or it's where it's like a wallet address, similar to wallet address. Yeah.
Okay, got it. Thank you.
All right. Yeah, one of the things here, another interesting thing is mapping values. So, yeah. Just go to contracts. So contract metadata is like too many informations, but this is where you decide that what is the Solidity compiler version you want, basically like here. What would be the address? What would be the URL? I mean, you have too many things here, but mainly you require this. This is very important, the compiler version, right? And this is where you can basically compile your program with many versions in order to test that if some player is running the version, very old one, you can test it by changing this just version here and just compile the program and run it. One thing that I want to show here is the mapping basically. So in Solidity, you don't just search it, right? Yeah, mapping types. So once you declare a variable, you basically assign some value to it, right? And that's where, Solidity, it's called mapping. So if you create an address or something like that, you need to specifically decide that this particular value will store this type of data, and that we call a mapping. And that is very important in order to basically specify. So if you have a experience with languages where there is no immutability allowed, such as function-based languages, that then this will come very like handy to you. But if not, then this comes a little bit tricky because we are very used to just declaring variable, assigning value to it, and not using or basically let garbage collection do its job. It's not the case here in Solidity. You don't have garbage collection. It's a function-based language, so you have to declare everything and you have to assign value to everything. Basically, your compiler won't let you compile anything the first time, so you won't have that issue anyway. But in order to assign a value to its type, that's where mapping comes in. Mapping is basically it's a way to assign value to variables or type to variables, and then you can use any value to that variable in order to just declare it. This I will share the link each of it to do that. And this is the you should refer only this documentation page. This is very common, updated, and you can just copy paste and run the programs if you want to. Okay, let's come to Swarm. So how you can actually run Swarm. Like I said, Swarm is a peer-to-peer distributed file storage that runs on Ethereum network, and it's completely decentralized. You can use Swarm to store your files. You can use Swarm to store or write an abstraction to store database kind of information, a binary information, images, videos, whatever you want to. And if you want to basically install it, then you just go here for TF developers. And you will find a similarity in Swarm and IPFS. The only issue would be that Swarm is completely Ethereum based network. So yeah, if you want to install, I'll just show you that here. Can anyone mute please? There is some background noise. So this is a public Swarm gateway. Once you download Swarm locally in your machine, it looks like that. So for example, if you want to upload anything, let's just upload a file. Say this one. Click upload. Syncing here. And if you see, no matter what type of file is, at the end you get a hash. Now this technique is called content addressing. It is a little bit different, so let me just explain you. Till now, the HTTP module, the way HTTP handles the file is based on the name of the file, right? Like abc.jpg or anything. But the problem with these things are finding that kind of files is very, very difficult into the network. You need to know the name, anything, and you need to know where that file is. That's how our HTTP and DNS system works. Once you type the name of the publicly accessible file, your browser contacts the server, so looks for the file through the DNS. Then once it finds the server location, And if the file exists over there, it will return you back. In IPFS and in Ethereum Swarm, they use content addressing, where each content is addressed through a hash. Now, where the file is stored is none of the concern. It can be stored in a complete network or it's on one peer. But if you request from anywhere using the hash, the network will basically find that file and basically return it back to you. And let's just see that. So we just copy it here. Let me just share it in the chat so all of you can actually see that. There's a chat here, right? Okay. You can access that page. This is a file I just shared. You and everyone can see that. But if you see here, right, this is the hash. This is called content addressing. So if tomorrow I delete this file from my node, right, accidentally, or my node goes down, then even though my complete system is down, you can still access using this hash from other peers. And this content addressing basically is what proposed in to replace HTTP by IPFS as well. But instead of a naming and DNS kind of system, we use distributed content addressing format. So each of the file, no matter what type of file is given a hash, and each of the entries into the chain also is given a hash. So in the like blockchain world, you will hear this hash a lot. So hash is where basically you identify each and everything. You identify user by hash, you identify devices by hash, you identify files or any other actions by hash. So hashing is where everything becomes generic and unique, because your system won't repeat itself. And second, due to that, you don't need to have a complicated system to identify where this file is actually located. Here you see we are not giving a location, right? We are just giving a hash. And if in a traditional way, we just type a domain name and the exact path of the file. Here what we are doing is we are just giving a hash name, and that's all. I hope you guys got that. You can just also browse this from here. You see the upload hash. Sorry, I got that. All right. So if you just copy the hash, you need to give the file path name. Reset set. The hash and the code. All right. And we'll go into the little bit detail of Swarm and like smart contracts into the coming session. Let's move to IPFS, right? Do you guys have any questions so far about Ethereum smart contracts and anything like that?
Just one question,
Yeah.
Shahid. So remembering the file name is quite easy than storing the hash.
Well, basically, you don't need to remember the hash. Actually, that's the whole point. So once you develop an D app, you don't want user to actually remember the hash. So you name it using your normal ID system and whatever you want to. But at the backend layer, everything is managed through hash. So we are not expecting user to remember this hash, of course.
So for searching, if I put a name of something and on backend, that hash will automatically get generated.
Yeah, that's where the D apps comes in fast. That's where you need to develop. For example, if you are developing a image sharing application, right? Then if you want user to search by the name of the file, and of course you need to. Your job is to basically maintain the index, but if you want to retrieve the file from the network, you need to use the hash.
Okay, got it. Thank
Yeah.
you.
Okay. Let's go to IPFS. So IPFS is one of the projects by the protocol.ai team. Right, just go to protocol.ai project. So this is Protocol Labs. They have they are the guys who have built IPFS and LiquidToBe. All the stack actually you've seen into this. It's also called protocol.ai stacks. And IPFS is basically they have very ambitious goal to replace HTTP and make IPFS as a default file sharing system on the internet. And of course, IPFS uses the content addressing. So of course, every content is referred through hash. They have peer-to-peer network system. So there is no centralized storage and everything. But whatever good things I have talked about, they have it. And their system is like very simple. So let me just, how these things go up. How can I hide this thing? Anyone knows it? This is very annoying. All right, just go to 3.
You can take it to
Okay.
other screen.
Yeah, but it still comes up because I'm sharing all the tabs. Let me just navigate through
F11.
numbers. Okay. So first, let me have you guys download IPFS actually. Okay, IPFS installation. Installing from. Let me share this link. You guys can go and basically download this according to the system. So once you download it, you can choose whatever you want to. I believe majority of you are running either in Mac or Linux. Once you do that, let me show you what you actually need to do. So they will give you a zip file or extractive file. Once you do that, unextract it, then open your terminal and just go to the downloaded file. Okay, I have already actually downloaded it. So once you download the file, just unextract it and run this install.sh. If you do that, the IPFS will be stored as an executable file, and after that, all you need to do is run this command in the main repository. Since I've already done it, I'm not going to run this one. Once you initialize IPFS, you can just run the demo now to become a peer into the IPFS, which is IPFS demo. You don't need this one. I'm just running it because I want to enable purpose of experiment. Once you run this, you become a peer into the IPFS network. So yeah. And in order to check it, basically, you can just go to localhost 5001/webui. This is the dashboard of the IPFS. This is where you can see your status. You can see a shared file if you want to. You can see peers. So right now there is only one peer, but peers will basically come up as soon as the network boots up. So the handling of the peer and basically finding where next peer is, and all of these things, good things and complicated things, are done by LiquidToBe. So LiquidToBe is a core layer of IPFS. This is LiquidToBe. You can also install it as a separate module. LiquidToBe maintains the distributed hash table of each and every peer. LiquidToBe contacts those peers and add it in your list. It also manages the communication through transport layer. So these are all very, very complex and network layer thing has been done by LiquidToBe. So you don't need to do that. Once you install IPFS, LiquidToBe comes in with the package. As you can see, the peers are increasing, okay, all around the world now. Let me know if you guys have are installing actually, because I really want you to install and see it through instead of just watching it on my screen. So once you have multiple peers, there are more actually, they'll keep joining. You can see, so you can actually check the status here. right? Okay. So here, if you want to like upload any file into IPFS from the UI, you can just do it here. Let me just okay, let's just do this. So this is the file that is shared. If I want to just share it, the propagation of the file here takes a little bit of time because I've just booted my here. But you can see the file extension is just the hash. And like in Ethereum, we see the file type / name as well. Here you don't see even that. All you see is just the hash, and that's all. So now this file has gone to the IPFS.I, which is the global gateway for the IPFS. I'll share the link here as well, so you can see here. You don't need IPFS installed in order to basically see that. Okay, it will take time. All right. So you see, the IPFS allows you to store file, share it, and it uses the content addressing using distributed hash table and everything. Once you have installed it, yeah, IPFS Swarm install Truffle. Okay. The next suite that we want to install that will be required is a Truffle. All right, Truffle framework. Just go to this website. Suits Truffle. Sorry, Kanachi actually. So we'll install Kanachi. Here you can go and install this software called Kanachi. This is required. Basically, it will allow you to run Ethereum blockchain, private blockchain in your machine without actually have to copy entire blockchain into your machine. So this is like a fake chain, but it will allow you to actually develop your applications. Next is your Truffle. So Truffle can be installed via CLI. So you can install using just CLI. So Truffle CLI will allow you to kind of run Truffle command with your CLI mode, but you don't need that once you actually do. Okay, they've changed the model. Sorry. Take a little bit of time. And since we installed Ganache, right, and Truffle, you don't need Solidity compiler explicitly because Truffle will actually allow you to compile your smart contract. But if you don't want to use Truffle, you can use Solidity compiler. However, I highly recommend you use Truffle only. And let me show you how Ganache actually looks like. Install. Let's see if the Truffle is done. Okay. Search. Yeah. So Truffle is basically installed. So Truffle is a kind of a framework developed to create a Ethereum-based Solidity compiler-based project basically to write a smart contracts. It will allow, they have everything to compile, config, basically run everything along. And Kanashi actually will allow you to run private blockchain. So you can use addresses, you can use fake cryptocurrencies to fund your smart contract execution and everything. So I recommend you guys to install Kanashi and Truffle framework for Ethereum and IPFS for our protocol.ai based projects. Sorry. Oh, let me just show you how Ganashi actually looks like. Just installing it. Nega, that is good, bad. Let me just show you the image only. So I think my downloads will take a little time. But once you run it, you see a similar window like this. So here you have multiple addresses. These are fake Ethereum coins. And you can use these addresses in your program directly. For example, if you are writing a smart contract to transfer money from this address to this address, you can use both of these addresses, and you can see the real-time change to the blockchain. And also, you can use the RPC server to call any blockchain-based, Ethereum-based calls. So I think this is gonna take time. I'll just cancel it. I have installed in Ubuntu. So I think this is it for today's session, guys. If you have any doubt, any questions, or if you come up with any questions, you can come on talk to me on Hangout. So if you have any doubt, please let me know.
Hey Shahid,
Hi.
just one doubt I had. Like, what if I have two applications, decentralized applications built using two different tech stacks? For example, I have a decentralized file sharing application using based on Ethereum tech stack, and then I have a finance application based on blockchain tech stack. And now I want both of these decentralized apps to communicate with each other. So like, is that possible? Like, how to bridge and
Yeah, that's where LibP2P comes in. So
okay.
LibP2P is a generic module that allows you to write a, what the hell that window is? Okay, yeah. So this is a modular network stack. So if you want to basically bridge two different kind of net applications together into the decentralized space, then libp2p is the application where you can develop an abstraction layer. So your communication is run through libp2p only.
Yep. Okay.
Okay. If you want to try it, basically they have a SDK on every majority of the operating systems, such as for Go, for JavaScript, Rust, everything. You can try this one. I've tried it when I was basically exploring it. So you can use libp2p JS module to create a TCP layer, network layer based application. WebRTC, segment, everything. It's very fun.
All right.
Is that cleared up?
Yeah.
Cool.
Thank you.
Yeah. Anything else, guys? All right. I think everyone understood. Neelam?
Thanks, Shahid. I hope
Yeah.
everyone enjoyed the session. We'll be back next week. If you have any specific questions that you would want Shahid to address, you can drop me or Shahid a mail so that he's better prepared to answer your questions, or you can reach out to him offline as well. Till then, guys, please take really good care of your health and keep learning.
Thanks, everyone.
Yeah, thanks, Arhit.
Yeah, thank you.
Yeah,
Thank
thanks,
you, bye.
everyone. Yeah, bye-bye.
Bye.
Thanks, everyone. Bye.
Thank you.